Hello, welcome to this new video on QuPath. So today's goal is to show you how to draw specific regions on a brain slice like this one here and do some cell detection using StarDist and do some classification later on. So we have already seen some of those examples here, but I wanted to show this on a Mac and also really start from scratch to show you how you build your project, how you handle everything from A to Z. So let's start with QuPath. So the first step is to create a project folder here. Let's rename this as my project, for instance. And here we now have to select this folder by using create project. So here, select my project, here, okay. And now we have to add some images to this project. So I have some example images here. I will just drag and drop it on the project, and I have to set up the image type here. So the image type is fluorescence, and I will let everything else by default. Usually QuPath does a good job of handling those files. So I can now import the images here, and if I want to open up one of those images here, I will just need to double click, for instance, on an image like here, or this one, for instance. So now the next step is to draw regions. So in QuPath, regions are called annotations here, and you can use those tools above here to draw those annotations. The simplest part, the simplest tool is probably the polygon tool. It's the fastest because you have just to click and outline the region you want to draw, like this, and double click to finish. So obviously this is less than ideal, but it's a good start. Let me show you another option. The other option would be to use the brush tool. So the brush tool allows you to really draw the region by brushing here. And there are several tricks. So let me just enable showing the input display, so that in this small panel here, down here, you will see all the keys I'm using. So when you draw a region with a brush tool, you can expand it by clicking from inside to the outside here, or if you click with the Alt key pressed from the outside, you can remove part of the regions like this. The drawing with the brush is also sensitive to the zoom level. So let's say, for instance, I draw something like this here, but now if I zoom in, I do the same thing here, or if I zoom out, you can see that the drawing is really dependent on the zoom level. So that allows you to work quite fast by just changing the zoom level. So the last tool is the wand tool. The wand tool allows you to automatically draw regions by taking into account what's under the cursor. That means that here I'm displaying all the three channels. We have, let me click here to show the brightness contrast dialog. We have three channels, 555, 488, and DAPI. And let's say if I want to draw something that stops here at the border, I can use my wand tool, and it will stop here because there is a clear contrast delimitation with the DAPI signal, so that you can see it. But if you're interested, for instance, in other regions, here it can become quite messy because, let me just zoom in a bit here, for instance here, because you have a delimitation between the red and the green, so it's a bit spotty like this, it's complicated. A workaround would be to disable everything else but the red, for instance, and now if I start to draw with the wand tool, it's a bit cleaner, like you can see here. It's easier. So that's how those tools work. So there's also another thing that is useful is to use some region arithmetics. Let's say you have something that you want to design with the brush. So what I will do here, just close this panel for getting a bit more real estate. I will delete all those annotations here and try to draw the cortex part correctly. And I will show you about how to use the annotation arithmetics. So what I would do here probably is start, let's start with the brush to get a really rough outline like this of the region I'm interested in, and we will just refine it later on. Something like this. Okay. And now I will zoom in again, and I will use the wand tool with the Alt key here to remove the parts that I'm not interested in. And here I will probably just display the green channel. Come on. And let's just remove those parts here. So I can also use the wand to expand, but it's a bit harsh because here probably too zoomed in. Yeah, something like this should do the trick. For this part, I guess, yeah, maybe you can expand a bit more here or remove it. So I don't want to be too precise here, it's really just to give you an idea. Don't forget to switch back to the move tool if you want to reposition the sample here. Or you can also use the brush here to edit a bit some of the region that you are not interested in. And let's say now you want to, you can just include a bit more here, like this, finish. Alt key to remove this. Let's say I want to do a clear cut here, or really a line to remove this part. What I can do is use this polygon tool and draw this line where I want to do the clear cut and finish the region like this. And I want to subtract this region from this annotation. So what I can do now is, so you have to really be aware that there is a specific order to do that. You can select multiple regions by pressing Shift here, but the order matters. You have always to select the region you want to keep, the annotation you want to keep, as the last one. So I will start with the one I want to subtract and Shift select the one I want to keep, and then I can right click here on this group and choose edit multiple and subtract selected. If I do that, nothing looks to have changed here, but actually if you just click again here, you see the clear cut. So this is an overall view of the tool that you can use to draw the regions. There are more tools like expanding regions and things like that with a specific diameter, but I won't go into that today. So let's just set up the properties for this one and call it cortex. Yeah, we can leave this in red and draw quickly another one for the striatum region, like here. So obviously it's not very precise, but it will do the job. If we want to refine this, well, it's up to you to do a better job than me. Okay, anyway, so you get the idea. Let's give this one a name as well. And change the color to, let's say, blue, something like this. Okay, so this was how to draw regions, and this is quite useful, and also to name those regions, those annotations, because later on in the statistics it will be easier to identify where those statistics come from, if they have a correct naming. So the next step is to use StarDist to count the cells. So there are two ways to count the cells, with or without StarDist. So let's use, for instance, the striatum, and let me just use the DAPI to show the cells. Obviously, there are some of them there, but we don't see them really much because the border is so bright here. But there are many cells that you can see here. So the default tool that comes with QuPath is located in the Analyze menu, and is called Cell Detection. There's also positive cell detection if you wanted to, and there are other options, but here this is the one you should use normally. The only problem is that with such a dense collection of cells like this here, it will probably have a hard time to figure out how to use those cells, how to detect the cells. So the first thing is that you have to set up those parameters with the minimum error, maximum error, and so on. You can also define cell expansion if it's useful for you, because by default it detects nucleus and then expands from the nucleus to draw regions around. So here I just put this to 0 just to show you how it works as an example with the default parameters. So it does a decent job, I mean, but it's probably not the best solution you can have. So as an alternative here, you can use QuPath, StarDist to have a better cell detection. So in order to do that, I will first remove all those detections, obviously, so I can delete all the detections here. Yes. And I need so now to configure StarDist. So StarDist is an extension. So you can view here at in the extension menu, installed extensions, if StarDist is already installed. I strongly recommend to install it. It's not that complicated to install it. Actually, you can just go to the help menu, view documentation. If you go a bit down, there is the StarDist here line, and there is all the links here to download both the StarDist extension and the pre-trained models. So let me just quickly show you. Open this in a new tab. So when you get to this GitHub page for getting the StarDist extension, you just go here to download. This page seems to have changed. Where is it? Blah blah blah. Oh, they have changed it. So normally you have to go to the release page. Where is it? Release here. It's the latest. And you can now download the this .jar file. Let me just click this here. I will save this. Come on. I will open the folder where it is. So I have already downloaded previously, but you get the idea. And then to install it, you can just drag and drop over StarDist, our QuPath like this to install the extension. Here it's already done, so it will not do it again. The next step is to get the pre-trained models. Since it's a machine learning algorithm, it needs models to work, and you can get those pre-trained models here the same way. It's a GitHub page, and there are several models available. If you are just interested in the fluorescence images, for the fluorescence images, you have to use this one, DSB 2018 Heavy Augment. This is the model that will be used, and I think we already have it downloaded. Just check. Yeah, it's here. DSB 2018 Heavy Augment. Okay. So we have everything that we need at this point. We can just close this. And the next step is to use a script, because StarDist works with a script. So with QuPath, you have the automate menu. You can show the script editor here, and you can type some code here. The other way to use this is by using the workflow tab and try to automate some of the steps that you have done. Actually, only the things that are not done by a human can be automated. So for instance, everything that I drew manually was not recorded here. You can just use the functions that I've called: set image type, delete, and so on. So to get the right script for that, again, you can just go to the documentation, StarDist. You have example scripts here, and for the fluorescence, you will have to use this this one, so the one that is over the fluorescence image. So you can just really simply copy and paste this script here, and there is just one thing that you have to change, is the path to the model. Currently my model is stored in my downloads folder here, so it's this one here. And the easiest way is that if you have enabled the shortcuts here, it's a preference in the Finder tool that you can enable. You can just right-click here and copy the name of the file as a path name. So it's really fast, and you can just replace this here, paste, and then you get directly the right path to the model. You have to make sure that the right channel is used, so here it's obviously DAPI that is used, so this is fine. And the next step is maybe include more options with StarDist, like probably adding measurements. So on this page here, you have more options. Let me just see here. For instance, you can have measure shape and measure intensity. Those are options that you can add as things that will be done by using directly within the detection step. So let's paste this here. Just have to make sure that the indentation is the same, otherwise it won't work properly on some systems. And then we can just run and see if the cell detection works. So run the script. It says it's running. And let's see the result. So you can see the detection is much better than the default cell detection. There are ways to refine this detection by changing a bit the parameters, like adding changing the threshold if you want to be more drastic about how many cells you want to detect and so on, because this is based again on a machine learning algorithm. That means each of those cells have a probability, and the threshold here will define what level of probability you want to keep to make sure that those are cells and not other objects. So anyway, let's keep this parameter here, and we will save this script so that we can reuse it afterwards. So here I will save this script as, and I give it a name, StarDist cell detection. Yeah, it's better if I type this correctly, detection, like this. Oh, come on. StarDist, and save. So now if I click on the QuPath window here, if I go to automate project script, I have my script directly here that I can call. It will open up the script editor panel, and then I can just press run or command R to run the script, which is quite neat. The thing is that it will be saved with the project, which is quite nice. So let's do the same step on the cortex part. So let's use command here, command R. So again, cell detection is running. Since it's a larger area, it will take more time, but it's just to give you an idea. So here you can see that some of the detection were missed because of some errors, but anyway, happens sometimes. The overall result is still very good. So now we have detected our cells, and it's quite nice. The next step is to classify them, because as a reminder, we have 3 colors here. And we want to classify cells whether they have some blue signal or some, some green signal or some red signal. So in order to do that properly, we will have to just close those windows here, to do a bit of preparation. So I will use another image to do the training, because we will train an algorithm to do that, a machine learning algorithm, a classifier. And we also want to do this on several other channels. So because we can't use the same image, it's not really a good idea. So let's use the next one here. I want to save what I've done here. And what I want to do here, if I go to classify, I have a menu that's called training images, and I want to create duplicate channel training images. And I want to do that for the 555 and 488 channels. I don't need the DAPI, since this is the one channel that I've used to detect those cells. So obviously they will have some blue signal. Press OK here, and now I have those two same images. Then this one, it's just copies, and I will now start, let's say, with the 488 one. I want to just detect some cells first. So let's draw a small region where I have, just see, green and red cells. I want to have a sample where I have a representative let's say we need to see all the different cases we will encounter. So green cells, red cells, green and red cells, and so on. And I can run the StarDist cell detection. So Command R to run the cell detection just on this small area here. And now what I want to do is to simplify my job, just show only the green channel, since we are working on the green channel here. And let me just see here, on the annotation tab you have the list of the classes. I want to also add classes for my channels. So I can go here to the small dot and populate from image channels. I want to keep the existing classes, yes. And now I have new classes for my channels. So this is quite nice. And what I want to do now is let me just zoom in so you'll see a bit better. What I want to do, let me just expand this window actually, is to define annotations and classify them, whether they have green signals in them or not. So it's not very complicated. I will choose AF488 here as a class, and let's say, okay, let's draw a region here and say this should be AF488 and so on. So I'll choose this one as well, this one, this one. This one, and so on. I can do a few examples. It's quite useful to have various situations as well, because we are training an algorithm to identify those cells. And now I want to use the ignore class here to set up examples of cells that are not considered as green. So this will be ignore, this will be ignore. It's a good idea also to go close to other cells that should be green. So for instance here, this one, those groups, ignore, and so on. I can be a bit more wide by using this here. The brush tool again. So I have different backgrounds or examples as classes that I should ignore. So this looks okay to me. And now I will select back my default annotation here, and I will go to classify, object classification, and train object classifier. Here what I want to do now is make sure that I don't have random classes. Normally here I can see that, but sometimes it happens that if you have, especially if you have auto sets, where you, instead of clicking each time to set class, you automatically set the class from the class that's selected here when you draw annotations, you can end up with many classes. So since I've been burnt many times, I really make sure to here make selected classes that choose only the one I want to use, so AF488, and ignore. So here we can revert this like this, and now we can press live update, and it's probably easier if we fill in the detection. So you will see in red detections that are ignored, and in green detection that are considered as positive, so as green. And you can change the opacity here to see if this is really correct or not. So for instance here it's considered as positive, but it shouldn't. So let me just add another example here and set this to ignore. So now instantly it will update the classifier. So once you're satisfied with your classification, you can save this as AF488 classifier. Oops. Like this. And now we will do the same with the other image here. So we can double click, we save the changes here. So it displays exactly the same field. Let's use the same, or roughly the same region. We have to detect the cells, so project script, here it is. Let's run it, Command R. The cells have been detected here. You can close the script window. Here in annotations, I can just close this also. Yeah, I know. We will now do the same with the other channel. So the red, actually, like this. So this is a bit too harsh, as I said. We need to tone this down a bit. Okay. And also here I don't want to fill the annotations, if not I won't see anything. Something like this works for me, so you can just close this, and we will do exactly the same as before. So I will draw some regions, some annotations, and set them to the AF555 class. So for instance here, this one, those three here. I can choose ignore for here. I want to ignore this one here. And so on. Let's ignore all those as well. Ignore. And let's add just a few more positive to the mix. Okay. So let's see the result. We select this, classify, object classification, train object classifier, live update. And here we don't see anything actually, since both the default and the class is red. So in order to just see something here, we can just double click and change the color to something else. Let's choose yellow. So now we can see, if I fill the regions, it will be better. If the classifier works okay, yeah, I think it's okay. If it's not, you can refine this. For me, I think it's okay. So let's save this as AF 555 classifier and save this. So now we have two classifiers, one for the green, one for the red. So let's go back to our original image here. I want to save the changes here. Sorry. No, sorry, it was this one. Yep. And enable all the channels here. We see the cells. And now what we can do, if I select the annotation here, is go to classify, object classification, and we want to create now a composite classifier. So since we have two classifiers saved, we want to apply those two here, and we will give it a name, composite AF488 AF555 classifier. You can save and apply, and now you can see all the cells, the green, the red, and the other one. And if you look here at the classes, you can see there are 24,000 detections, so 24,000 cells. 812 of them are positive in green, 333 of them are positive in red, and 24 of them have the double classification. So that means that they are both green and red, which is quite nice. I shouldn't have probably used the yellow as a classifier, color for the classifier. I can change this back to red here. Yeah, maybe it's not a good idea. Let's choose something else. Purple? Magenta. Let's use magenta. So you see magenta here, green here. I don't know where the double classified, but the color of those double classified should be specific. Actually, if you populate from existing objects, including the subclasses here, I want to keep the existing classes and press yes. Yeah, you get now the double classified here. So I can give those a specific color. Let's put them, I don't know, in cyan, something that would stand out. Probably. And do we see some of them? Yeah, here they are. Or even if you put them in yellow, it's probably even a better idea. Like this. So now we see them. So that's how we should work. By the way, let's add just an automation step so that you can in one go detect the cells and classify them. Since we have now saved everything, let me just show you here the striatum region. We can now go to classify, object classification, load object classifier here, and we can choose Composite AF classifier, apply it. Come on. Is it doing it? Let me just see. Yeah, here. Run object classifier. It's here. It was already detected since actually the two regions were selected. But what I want to use here is this step here. So I can choose create workflow from the workflow tab. I want to keep only the last step. So select and remove selected items. Yes. And create script so that I can just get this command here. So let's copy it into my StarDist script here. And I can add it as a second step. Paste. Oh, come on. Didn't copy the right lines. Sorry. Here. Command C. Command V. Yeah. And let's just save this as cell detection and classify. Say like that. So let's try it. I will just draw a small area here and call this new script automate StarDist cell detection and classify to see if it works in one go. So can run the script. Let's see the results. Yep, cells are detected and automatically classified. So just in one go. So it's pretty fast. Okay, so this is pretty much everything you need to know how to detect cells and classify them on those fluorescent images. The last thing I want to add is that if I save now this project, my scripts are saved, my models are saved, everything is saved inside the My Project folder, which is here. Let me just show you how it looks like. So you have the classifiers here, that are here, and the scripts, which are here. So if you want to reuse those classifiers and scripts, what you need to do is just add some images to this project, and it will work without any issues. So that's it. If you have enjoyed this video, please leave a comment, or if you have remarks or anything you want to add, you're welcome. So have a nice day. Bye bye.